Hello, hello, everybody. Hello, this is Uma Garg, and I am currently a faculty member at Chinta Physics Department. I mentor students for the preparation of Physics Olympiad program. Currently, we offer intermediate and junior program. Intermediate is calculus-based physics program, and intermediate is junior is non-calculus based program, whereas intermediate program is for calculus-based sessions. So today we will do projectile motion, and I will walk you through the basics of it, and we will do some questions on projectile motion, and after that I will introduce you to, with the Chinta Physics Olympiad program. So let's start with the projectile motion now. So, what is meant by projectile motion? Projectile motion is an object which is projected into space and moves under the action of force of gravity. The only force acting on a projectile is gravitational force. So basically, a projectile is an object on which only gravitation force is acting. So when we drop an object on a floor, like for instance, we have a ball and then we drop this ball on floor, then this is not a projectile. Motion is basically when an object is thrown in force and it is projected at some angle with the floor. So let's say it's making angle theta with the floor. So this is the projectile motion. So now when the trajectory of such a projectile is curved, and its curved path, and during its motion, so its projectile motion is basically a two-dimensional motion. It's a two-dimensional motion in x and y direction. Okay, so this is the projectile, and it is projected here. So it's moving in x direction. It has two coordinates associated with it. So this is the x coordinate, and here it's the y coordinate. So it's moving in horizontal direction, and that is why its x coordinate is changing, and then it is moving in y direction also, and its height is changing with respect to the ground. So therefore we call it a two-dimensional motion. Now projectile is thrown at some angle with respect to ground. So this is the initial velocity of projectile. Let's say the initial speed of the projectile is u meters per second. So it makes some angle with the ground. So due to this, because it is projected at some angle, it follows a curved path, and we will look further when we go into the basics of it. Then we will understand that it follows the curved path. Okay, now when we throw a ball vertically on the floor, this is not a projectile motion. Okay, even though gravity is still acting on it, but we don't call it a projectile motion. Okay, it's a straight line, it's a linear straight line motion in straight line or one dimensional motion in straight line, or we call it a one-dimensional motion. Okay, so now this has two components of so this is the speed with which it is projected. Now the maximum distance that this projectile travels, we call it a range. So let's look at this figure now. Okay, any questions so far on projectile motion? Simran, hello. Okay, so there are this is how projectile motion looks like. I introduced previously also. So a ball is projected. In this figure we have a ball that is projected with velocity u, with speed u, and it makes angle theta with respect to ground. So ground, so we are fixing direction in ground, and y is the vertical direction above the ground. Okay, so now we can write initial velocity of projectile as initial velocity of projectile in a vector form. It will be two-dimensional, right? The velocity will have two components. One component will be along x direction and the other component will be along y direction. So we can write initial velocity of projectile as u equals to, so its x component will be u cos theta and y component will be u sin theta. Okay, so we can write initial velocity in vector form as u cos theta I cap plus u sin theta j cap. Okay, um, so this is the initial velocity of projectile motion. Now since we will solve projectile motion by applying equations of motion. Now we have three equations of motion, but these equations of motion are only for one dimensional motion. Okay, so we will solve projectile motion in x direction and y direction separately. Okay, so there are three equations of motion that we are familiar with. First one is v equals to u plus at, and then we have s equals to ut plus half of at square, and then we have v square equals to u square plus 2as. Right, these are the three equations of motion. Here v equals to final velocity, u equals to initial velocity, a is acceleration, y is s is displacement, right, and t is time. Okay, so these are the three equations of motion, and we will use these equations of motion to solve this projectile motion. Now since this projectile motion is in two dimensions, we can't apply for both x and y simultaneously. So we will separately solve for x direction, motion along x direction, and then so these are independent. Motion along x direction and y direction, they are independent. Okay, so we will apply equations of motion separately for them. So motion along x and y direction are independent. Okay, so we will apply equations of motion separately for both of them. Okay, so let's solve for x direction. Motion along x direction, let's look at that. So in the x direction, along x direction, is there any force acting? No, there is no force acting. There is no force acting. Okay, so the projectile will so we know, right, for an object to accelerate, when does an object accelerate? When its velocity changes, and when its velocity changes, either the direction of object changes or the speed of object changes, right? So if there is no force acting on an object, there won't be any change in velocity. Okay, so therefore no change in velocity happens. As there is no force present, no change in velocity, no velocity change is happening. Okay, so therefore projectile does not accelerate. Projectile does not accelerate along x direction. Okay, as there is no force acting along x direction, it does not accelerate and its velocity does not change. No velocity change is happening along x direction. So initially along x direction, the projectile had what was the velocity of projectile along x direction? It was u cos theta. So it remains same throughout the motion till it reaches here. Okay, so this is the total path that projectile is traveling from point, let's call this point O, and let's call this point P. So from O to P, there is no change in velocity along x direction. Okay, so it remains the same. Okay, so initial velocity of projectile in x direction equals to the final velocity of projectile in x direction, because no force is acting along x direction. Okay, now so for x direction, we can straight away write that the horizontal distance is basically in this case there is no direction reverse is happening, we can say horizontal displacement along x direction is equal to the distance traveled by projectile, is equal to the distance traveled by projectile along x direction. Okay, and so applying the equation of motion, we have this second equation of motion. Okay, what is that? S equals to ut plus half of at square. Now there is no acceleration along x direction, right? So a is 0 for x direction, right, since no force is acting on projectile along this direction. Hi Vishnu. So yeah, first I want to discuss the theory, and then we will do couple of problems. Okay, and then there will be part 2 that I will be doing next week. So we will do more challenging problems there next week. Okay, so a is 0 for x direction. So we will since a is 0 for x direction, so this part goes away, so this becomes 0. Okay, so so we can say s is basically x, which is the distance in x direction. Okay, so I'm replacing s with x, which is the displacement in x direction, and u initial. What is the u is basically initial velocity. So in place of s, we will put the displacement in x direction, and in place of u, we will put the initial velocity in x direction. So what is the u for x direction? U cos theta, right? Or I can write subscripts sx. So which this means displacement in x direction, and then we have uxt, which is displacement in which is initial velocity in x direction. Okay, so I can replace. So Vishnu, are you like familiar with theory part? So uxt, and basically, and this is axt. Okay, so ux is basically u cos theta, which is the initial velocity of projectile along x direction. So x will be equal to, and I am writing sx as x. So x equals to u cos theta times t. Okay, so this is our displacement along x direction. So now there is a special name for the total distance that projectile travels during its complete motion. We call it range. Okay, so this is the total distance. This is the total distance projectile travels along x direction. Okay, So let's say t is the total time of flight of projectile. T is total time of flight of projectile. So x will be equal to range. So I can write range of projectile, which is range of projectile equals to u cos theta times the total time. Okay, so this will be the range of projectile. Okay, so let's call this equation A. Okay, good to know. Okay, so this is u cos theta into total time t. Okay, okay, you are in 11th grade. Then, yeah, I am basically here addressing the general audience. We have a lot of students from 7th standard, 8th standard. So that is why I first wanted to introduce the audience with general projectile motion and the basics of it. And then I will take problems. Today I will do couple of problems in next week as well. We will do some complicated problems on this topic. Okay, so R is the range of projectile motion. Now we will solve for motion along y direction. Okay, so along y direction. So along y direction we have uy. What is the initial uy is the initial velocity along y direction, and it is equal to u sine theta, right? Okay. So initial velocity along y direction is u sine theta, right? So we will put initial velocity uy is equal to u sine theta, and what will be the acceleration along y direction? A along y direction, acceleration along y direction will be minus g, right? Because gravity is acting on the projectile, right? In this, so ay will be this, and so let's bring this picture again back here. Okay, so this was the picture I showed for the projectile motion. Okay, so now here, since this is a symmetric motion, right? So this is the symmetric motion. So the and t is the total time projectile is taking to travel from this point O to P, right? So this is t is the total time of projectile. Okay, so now it's a symmetric motion, right? So half the time, so the time, this is the maximum height projectile is taking. So from O to A, at point A the projectile reaches at the highest point. Okay, at A projectile reaches the highest point. Projectile reaches the highest point. Okay, yeah, Shri Pranad, we will send you the rough syllabus for this. Thank you. Are you a part of Chinta? I will connect. I will, if so, then we will ask one of your team, one of our team member to connect with you, and we will send you a rough syllabus. Okay. So at point A, this projectile reaches the highest point. Okay. So at the highest point, this the projectile is not moving in the along the y direction anymore. Okay, so its velocity will only be in along x direction at the highest point of projectile motion. Okay, so at the point A, it reaches the maximum height, and we are denoting h, capital H, as this is the maximum height. H is the maximum height of projectile motion. Okay, so, and at point A, there is, at point A, uh, at point A, Vy, or the velocity of projectile along y direction is 0. Only horizontal component, only horizontal component is present. Okay, so now I can use this fact to solve for this motion along y direction. And also, since this path is symmetric, right? So it will take, so total time of projectile is capital T. So it will, in t by 2 time, it will reach from O to A, and in another t by 2 time, it will reach from A to P. Okay, so the time taken by projectile, time taken by projectile to reach from O to A equals to t divided by 2. Okay, half the total time of projectile motion. Okay, so it's t by 2. So we and we know uy and ay. So uy we know is u sine theta, and ay equals to minus g. Okay, so I will use these things, okay, to solve the projectile motion, okay, along y direction. So first we need to find what is h. Okay, in terms of our velocity, that information that we have, what is the maximum height? H is the maximum height. So first we want to solve for that. Okay, so I will apply third equation of motion, which is given as vy square equals to uy square plus 2as, right? Now vy is 0, right, at point A. So I am right now talking about the maximum height. Okay, I want to solve for maximum height. Okay, so I am splitting this into this part here. So at point A, so this is my initial point right now. Okay, and this is my final point from O to A. So at this final point, okay, yeah, the total time, total trajectory of projectile is from O to P, but I am right now interested in this part only, from O to A, right? So this becomes my initial point, and this becomes my final point. Okay, so now at point A, this becomes so at point A, uy becomes 0, right? Vy, sorry, final velocity becomes 0. Okay, so vy is 0. Okay, and we know uy and we know a value, right? So and s we will replace by minus h. Okay, since the displacement is negative, we are putting negative sign here. Okay, so now let's solve for this. So I am putting these values here. 0 equals to uy is u sine theta whole square minus 2. A will be replaced by, okay, so let's call this h only. We will automatically get negative sign for that. So this will be minus, A will be replaced by G, and H will be replaced by, and S will be replaced by H. Okay, so from here, H will be, the maximum height will be equal to U sine square, or U square sine square theta divided by 2G. So this is the expression for maximum height of projectile motion. Okay, in terms of velocity and the angle of projection. Theta is the angle with which projectile is projected. okay, from the ground. Okay, so if in a numerical question theta is given to you, initial speed is given to you, and we know g, value of g, you can get the maximum height of the projectile. Okay. Okay, now we also want to get, let me get that figure back here just for your reference. No, I don't want this right now. So we have got maximum height of projectile. Okay, so now we will get the time also, total time of flight. Okay, so you again from this point O to P, O to A, I will consider from O to A. Okay, so from O to A, at point A, I can again solve. I will apply first equation of motion, Vy equals to Uy plus At, right? So at point A, Vy is 0, right? Velocity is only along x direction, which is which is u cos theta, right? Velocity along x direction doesn't change. I told you earlier as well, because there is no force acting on projectile along x direction. The only force that is acting on projectile is gravitational force that is acting along y direction. Okay, so there will not be any change in speed along x direction. It remains same. So initially, the component of velocity along x direction is u cos theta, so it will remain u cos theta throughout the projectile motion till it reaches here. Here also it's u cos theta. Okay, now, so Vy is 0, and Uy we know, u sin theta. Uy is u sin theta. Okay, so I will put, and t from O to A, how much time it is taking? Capital T divided by 2, right? Capital T is the total time of projectile. So I'm putting these values here. So Vy is 0, Uy is u sin theta, minus A is replaced by negative g, and time I will replace by capital T upon 2. So from here, the total time of flight of projectile will be 2u sin theta divided by g. So this is the total time of projectile motion. Okay. Okay. So now we will solve for so now we will solve for, so we have got the range, we have got the total time of we have got the maximum height, we have got the total time of projectile. Now we will solve for range of projectile motion. Okay, so range of projectile motion, I told you earlier, is given as u cos theta, which is the speed, right, along x direction, multiply with the total time, right? That gives you the total horizontal distance projectile has traveled along x direction. So this complete thing from here to here, this is the distance it has traveled in x direction, right? From here to here, this is the range of projectile motion. Okay, and it is given as, so for const when there is no acceleration, so distance is just speed multiplied by time, right? Total time. So speed is u cos theta along x direction, and the total time is capital T. So range is given as u cos theta multiplied with t, capital T. And we know capital T, I can replace it with this, right? I got an expression for capital T, 2u sin theta divided by g. So I will replace it here with that. So u cos theta, 2u sin theta g. So r will be equal to then u square sine 2 theta divided by g. Okay, so this is the range of projectile motion. Okay, so this is the basic of projectile motion. Now at what angle, so this is the range, right? So at what angle should I project, so that I get the maximum range of projectile? Okay, so we know sine theta, so we know sine theta lies between, what is the max value of sine theta or sine 2 theta? Basically it can go from -1 and +1, right? So range is a distance basically, so we are ignoring the negative side, so it can be at max equal to 1 or less than 1, right? So to get the maximum range, we want sine 2 theta to be equal to 1. Okay, okay, so sine 2, for getting the maximum range, we need sine 2 theta equals to 1. So from here 2 theta, so when is sine 2 theta 1? When this 2 theta will be equal to 90 degrees, right? So from here, theta will be equal to 45 degrees. Okay. So if we project a projectile at 45 degrees, then we will get the maximum range of projectile motion for that particular speed. Okay. Okay. So this is the formula for maximum range. Okay. And now we will do some questions based on projectile motion. So this is our first question on projectile motion. Which of the following paths, 1 and 2 of the of projectile motion, has more time of flight? Okay, so these are the two paths of projectile motion. This is x direction and this is y direction. So which of the following paths of projectile motion has more time of flight? So how we will tell that? So we can see from this figure, both have the same maximum height, right? So the maximum height of projectile motion is same for both, right? So this also has the maximum height it takes is capital H, and this one also takes capital H. This is the maximum height of this projectile motion, right? So now we know the height of projectile motion. So height of projectile motion, we know the expression for that. Is given as, we know the formula for that, and it's u square sine square theta divided by 2g. Okay, so now these are our projectile motion. This is our projectile. So let's call this as, so let's say this projectile is this first projectile is thrown with speed u v1. Okay, and this project, and it makes angle theta 1. Okay, with respect to ground. And the other projectile is thrown with v2, speed v2, with respect to ground, and it is thrown at angle theta 2. Okay, with respect to ground. Okay, so I am defining it like this. Okay, so for projectile motion, for projectile 1 we have, it is thrown with speed v1 and it makes angle theta 1 with ground. Okay, and projectile 2 makes is thrown with speed v2 and theta 2. Okay, now we want to see whether they are reaching the ground at the same time, or which one is it, since it is traveling more distance, is it taking more time and this is taking less time? So we want to find out that. Okay, so now what will be the height, maximum height that will be covered for projectile 1? For projectile 1, capital H. So the maximum height is capital H, and we will replace this U with v1 and theta with theta1, right? These two parameters. So maximum height will be equal to v1 square sine square theta1 divided by 2g. And for projectile 2, okay, capital H, or the maximum height is v2 square sine square theta2 divided by 2g, right? Okay, now we can compare these two, right? And from 1 and 2, from these two, from 1 and 2, we get, when we compare v1 sine theta1 equals to v2 sine theta. These, the left side is equal, right? So this will give v1 sine theta1 equals to v2 sine theta2, right? So I get this, okay? And also we know what is the time of flight. Time of flight of projectile 1, time of flight of projectile 1. So what the general formula for time of flight of projectile is, um, 2u sine theta divided by g, okay? Yeah, 2u sine theta divided by g. So this is the time. So I can replace it. So now I will replace u with v1 for projectile 1, right? U with v1 and theta with theta1, okay? So time of projectile of time of flight of projectile 1 will be 2v1 sine theta1 divided by g, and time of projectile of, time of flight of projectile 2 is equal to 2v2 sine theta 2 divided by g, okay? So now we know v1 sine theta 1 equals to v2 sine theta 2. So this gives me that these two times, the times of these two projectiles will be same, okay? So let's call this t1 and t2, okay? Since v1 sine theta 1 equals to v2 sine theta 2, from here we conclude that t1 equals to t2. Yes, it will be same for both, okay? Yes, Ian. It will be same for both of them. Okay, so from here we conclude T1 equals to T2. So both projectiles will reach the ground at the same time. No matter this is traveling with fast, it has traveled more distance along x direction, but both will reach the same. As long as the height is same, the projectiles will reach the same, no matter at what angle they are projected, and if they are projected with greater speed or less speed. Okay, as long as the height is same, they are going to reach at the same time. Okay, so this was problem number 1, and we will do one more problem today. So this is the next one. A girl standing on a long railroad car throws a ball vertically upwards with 9.8 meter per second. So this is the long railroad car that we have. Yes, yes, Ian. As long as H max is same for both of them, they will take the same time, irrespective of their angle of projection and velocity of projection. Okay, so this is the long railroad car. Okay, and a girl is standing. Okay, on this railroad. Okay, so this is the road. Okay, pardon my drawing since I don't have too much control on my pen here. Okay, and so it's she has thrown ball vertically upwards. Okay, girl has thrown ball vertical upwards. So the y component of initial velocity. So let's denote it by uy. So uy is 9.8 meters per second. Okay, So this is the initial velocity with which the girl has projected this ball. But the ball will, for an observer who is standing on ground, it won't look to like it won't be following a vertical path for an observer who is standing on ground. For a girl, yes, it will look vertical. Throughout the motion, it will look vertical. The ball will look vertical to the ground, to the observer, to this girl. Okay, once she has thrown this ball, she will keep on seeing that it's going vertically in the sky, okay, till it reaches back here. But for an observer who's standing on the ground, it won't be following the vertical path, okay. It will follow this projectile path. Okay, why? So the girl has projected the ball vertically, right? So girl has initially given the velocity, right? This one, this velocity, u, right? Vy equals to 9.8 meter per second to this ball, okay. But since this railroad, this car is also moving, so it has velocity in x direction, right? And it is accelerating also. Yeah, these questions, yeah, we are doing a lot of questions that will be helpful for Olympiad as well as for JEE aspirants as well. Okay, so here, so this railroad car is also moving, right? With some, it has some velocity vx, and its velocity is changing, right? Because the car is accelerating at the rate of 1 meter per second square. Okay, so let's say so because the girl has given it velocity vy equals to 9.8 meter per second initially. Okay, but the car is also moving, right? So but when this ball leaves, when the girl throws this ball, the ball will have, because it is on the car, the girl is standing on the car, it will also have vuy associated, ux associated with it. Okay, so there will be two velocities that this ball will have. Okay, ux, which will be equal to the the velocity of the railroad car when the ball was thrown, and then there will be initial velocity in y direction, because which the girl has given. Okay, so this velocity is because girl projected it upward, vertically upward, right? Because girl projected it. Yeah, there is acceleration in the x direction, but ball, since once the ball is thrown, this it only gravity will act on it. Okay, the acceleration ball, once the ball leaves the girl's hand, it this acceleration of this railroad car won't matter on for the ball anymore. Okay, understood? So for once the ball leaves the when once the girl throws the ball, only gravity will act. Railroad will keep on accelerating. That is fine. But on car will accelerate due to gravity only. Okay, along y direction. Sorry, ball will accelerate only in y direction due to gravity. It will not. Ball will not accelerate along x direction. Okay, because it is in the sky, right? Railroad car is accelerating here, that's fine, but the ball is in the sky. Okay, it has nothing to do with the acceleration of this railroad car anymore. Okay, the only force acting on the ball is, yeah, for the ball, yes. So for the ball, the only force that is acting on the ball is the gravitational force. Okay, so ball will accelerate along y direction only. Okay, along x direction there won't be any acceleration for the ball. Okay, so this velocity uy, initial velocity, is 9.8 meter per second, right? And why is this velocity? Because girl projected ball vertically upward. Okay, because girl projected the ball vertically upward. Okay, so this is velocity component, and ux. Then there is one more velocity component, because once it leaves the ball, yeah, it will be like projectile motion, and ux will be equal to ux, which is the initial velocity of projectile, will be equal to the velocity of car, which we don't know, velocity of car when the ball is projected, when the ball is when the ball is projected. Okay, because girl is standing on this car, right? So ball is in the girl's hand, right? So when the ball does not leave the girl, when the girl has not thrown the ball, for an observer who is standing on the ground, ball is moving right along with the girl, and girl is moving along with the this car. So for an observer who is standing on the ground, ball and girl, they are both moving with velocity, right? With changing velocity, right? So they have velocity, right, along x direction for an observer on ground. But when it projects, right, but when the girl throws up, at the point when it leaves the girl's hand, it is having velocity of the car, right? Velocity equals to the velocity of car along x direction, and then there is one more velocity that the girl has given. Okay, so it becomes a projectile motion. Understood? So now for an observer on who is standing on ground, it won't be vertical, right? It will follow a projectile curved path like this. Okay, this, it will have projectile motion. Okay, now the question is asking you, I hope this is clear to you, all of you, that why it will be a projectile for an observer on ground. Okay, if it's still not clear, please do comment, ask in the comment box, and I will explain it again. Okay, so this is what we have here. Okay, now we don't know what is, so we are saying that initial velocity of projectile is ux. Okay, they haven't given the value, right? And the velocity of car is changing, right, because car is accelerating. So we have this, let me draw the figure again. Yeah, u sine theta will be 9.8 meter per second. Okay, now I'm drawing it again for here. So this is moving with acceleration a, meter per second square. Oh, sorry, 1 meter per second. They have given the value in this question. It's accelerating at the rate of 1 meter per second square. 1 meter per second square. Okay, and girl throws the ball. So we are saying that the compared to the length of this railroad car, girl's height is very small. So it's like we are saying that it's thrown from the base. Okay, so this is the girl and the ball is thrown. Okay, girl's height is very small compared to the railroad, so we can make this approximation. Okay, so now it to you it looks like it will fall forward, but this railroad is also moving, right? So after a while girl will also move from here. So this is girl. Okay, and she has thrown this ball here. Okay, so after a while ball will not fall here because this is also moving, so it will fall at the back of girl. Girl is accelerating in x direction, right, along with the railroad car. Okay, so it's not like it will fall behind the girl after time t. So right now it's thrown. I shouldn't complete this here. uh, it's basically, it's not going to fall like this. It will fall behind the girl because this is also moving. It's not stationary, right? It's not stationary, so it's not going to fall in front of girl. It will, the ball will fall at front, the back of girl. Okay, I wanted to show you. So this is moving with 1 meter per second, but as the ball is like thrown in the air, it will only experience g. Okay, yeah. So g, oh, it experience, yes, I am. So it will uh, uh, it will only experience g. Okay, acceleration due to gravity. Once it leaves the girl has thrown it, this 1 meter per second won't matter. Okay, for the ball will is going to accelerate at the rate of g in y direction, and it will not have, ball will not have, once the ball is thrown up by girl. Okay, it will only, okay, accelerate along y direction, okay, at the rate of 9.8 meter per second square, okay, it will have constant velocity. It will have constant velocity along x direction. This 1 meter per second square has nothing to do with the ball, because on ball is in air, it's not on car anymore, okay. It will just get the initial when it's thrown, the velocity that the railroad car will have at that point, it will only gain that. Acceleration, no. Okay. My internet becomes very slow when I turn on video, so I prefer to not turn on my video. Okay. I hope it's okay with everyone. So it will have constant velocity along x direction. Okay. So now let's solve this. Now I hope you all understand this question. So when ball, okay, it starts from here and it's going in this direction and it reaches back the railroad. What will be the displacement in y direction? So when ball completes its projectile motion, and reaches railroad car, then what will be the displacement in y direction? Displacement in y direction equals to 0, right? Because it starts from here. This is railroad car. It starts from here and it reaches back here, right? After completing its motion. So displacement along y direction is 0. There will be displacement in x direction, okay? But there will be displacement in x direction, but displacement along y direction is 0, okay? So this is 0 meters, okay? Yes, I am. So it will be 0. Now we can use this equation. Now I will apply this equation. Y equals to uyt plus half at square. So y is 0, right? For the from a to b, y is 0 meters, okay? And uy I know is 9.8 meter per second, and a is equal to minus a is equal to negative g, right? And I will take it as 9.8 meter per second minus 9.8 meter per second square. Okay, so I am going to substitute these values there. So 0 equals to uy is 9.8, okay, and time. So I am basically finding the total time it's taking to reach back the, once it's thrown from the by the girl, how much time will it take to fall back to the railroad car, okay? So 9.8 t, okay, minus half, and a will be replaced with g, which is minus 9 negative point minus 9.8. So negative I have already put there, and t square, okay. Okay, so from here I will get t equals to t into 9.8 minus 4.9t equals to 0, right? I will get this. Now t, so this means either t is 0 or this whole thing is 0, right? This implies either t is 0. Okay, let me clear this. I will, so this implies either t is 0, right? Or this whole thing is 0. 9.8 minus 4.9t is 0. Okay, so from here t equals to 2 seconds. Okay, So in the meanwhile, now 1 second, in the meanwhile the ball reach in, so in 2 seconds the ball will reach from A to B, right? Once it's thrown from the girl, it will take 2 seconds to reach back. Now in the meantime the railroad is also moving, right? So now I calculate the distance traveled by, now I will calculate what will be the distance traveled by projectile motion, projectile. Okay, distance traveled by projectile, distance traveled by projectile or by ball in x direction. So we don't know its initial velocity, right? Initial velocity of ball in x direction equals to the velocity of projectile of the railroad car at that time, right? So it will be uxt, right, which is ux 2 times ux, right? This is the distance traveled by ball in x direction. And what will be the distance traveled by railroad car? Distance traveled by, yes, it will be 2 meters. Very good. So distance traveled by railroad car during the same time. So I will apply that uxt plus half of uxt plus half of a t square, right? So ux we don't know, but they have same velocity, right? So ux and t is 2, right? I want to know the how much travel distance it has traveled in 2 seconds. Okay, plus half of a is 1 and this is 2 multiplied by 2. So this is equal to 2ux plus 2. So now the distance, so how, the question is asking how far behind the railroad car the ball will fall, right? So you can see the railroad car in 2 seconds, once ball leaves the, once girl throws the ball, the distance traveled by railroad car is more, right, than the ball, than the distance traveled by ball in x direction, because railroad car is accelerating, right, at the rate of 1 meter per second square, but the ball is not accelerating along x direction, right? So it's going to travel less distance as compared to the railroad car once it leaves, once the girl throws it. Okay, so the distance by, so the distance uh, the so, or we can say the ball will find, the ball will fall, the ball will fall, the ball will fall, how much, this is the extra, right? 2, it has traveled 2ux, and this is this railroad has traveled 2ux plus 2. So 2, it has traveled 2 meter extra, right? So the ball will fall 2 meter behind the car, 2 meter behind the car. Okay, so that's all for the questions today. So I hope you everyone enjoyed this session, and let me give you a brief introduction about the program. So I initially introduced myself. I am a mentor at faculty member at Chinta Physics Institute, and I mentor students for physics Olympiad programs. No, you have to take in general because it's moving, right? So when it was moving, no, if you take initial velocity of the railroad, yeah, that is fine, you can take, but at the time when the ball is thrown by the girl, it's moving, it's in motion, railroad car is in motion, otherwise it won't be a projectile motion anymore, right? Okay, so let me go back to that question. So you are saying initial velocity, Ian. So you are saying the initial velocity of the projectile motion, railroad car is 0. Okay, so this railroad car has started at some initial point, right, before this, before the ball was thrown, then we can say initial velocity. But when the ball is thrown, we can't say that it will be at rest, because if it is at rest when the ball is thrown, ball will not have projectile motion, ball will then fall vertically, it will rise vertically and it will fall vertically. Okay, but because it's saying, right, it's moving, it's in motion, right, it's in motion, so it has some initial velocity. When the ball was thrown, it had some initial velocity, but we don't know what was it. So that is why I took ux. Okay, I just kept it variable. here. Okay. Yes. Okay, so that's it for this, and let me just give you brief introduction about our program. So this is basically physics Olympiad program that we have here at Chinta. It is of two types. We have junior program, which is non-calculus, and then we have intermediate program, which is calculus based, and it's a 2-year course. And we take usually two group classes every week, and then there is a lab simulation section. Okay. Okay, let me put this information here as well for everyone to see. Okay, so this program is it's suitable for candidates who want to appear for NSEP exams and then Indian Physics Olympiad. After that, we once you clear this exam, NSEP exam, you appear for Indian Physics Olympiad exam and then for international physics. So we prepare for you for these examinations, and also those who wants to appear for these examinations, they can also take this course. And it's every week we take two group classes, and that are taught by me. Okay. And the classes are for 75 minutes, okay, on 2 days a week. And then we have a lab session. Yes. Yeah, class 11 students can also attend, so you have to select. So right now we are running a junior program. So you do you want to start with the uh, do you want to take calculus or non-calculus based course? Okay, so according to that, we will tell you. Okay, we'll give you the information. And then there is doubt session every week, so you can ask your doubts, whatever queries you have. If you haven't understood anything in class, you can ask. And this lab session and doubt session is taken by another teacher, but these two group classes every week, in which I okay, you want to take calculus? Yeah. Yeah, you can definitely connect with us, and we will give you more information about that. Okay. So yeah, so that's it for about this course. And uh, so you can take you can connect with our team members, and we will give you one trial class, and based on that you can decide. Okay. So I hope everyone attend liked this session and you learned something from it. And okay, have a great day. Thank you. Bye bye. I want to end this live session now. Okay, bye bye everybody. Any other question you have before I leave? Okay, thank you. Bye.